Oh wow, I forgot what this was. Alright. Okay, I have to change this. Which is the name? Back at it. I don't even know. Oh, fuck it. Move this here, actually. Okay. So this is to the left. Whoops. All right. So this is rotated to the left 1 bit position, and the contents of bit 7 are copied. Okay, to the ground flag, and the previous contents. Okay, so I'm guessing this is the same, but to the right. Makes sense. All right. So the only thing I have to change is this. Whoops. I don't know. Actually, let me do one thing. Stop stream. This should work. Let's write this to 4 and leave this like this. Okay. Wait, what? I already have this. Slim, yo, how you doing, man? I don't know if you can hear me correctly. Hopefully, yes. How you doing? How you doing? Alright. Alright, so I'm not even there. Where am I? Deck H? Deck H, yeah. Alright. Alt H and so basically I just have to load M into H. Okay, so CPU dot HL dot bytes dot high equals Are you programming a logic board? I am not. I'm programming a Z80 emulator. That's what I'm doing, which is a very old CPU, basically. It was released in 1976. So yeah, that's what I'm doing. No, except this is not what I have. Okay, so I just have to do this. Do you use an emulator? I mean, I'm trying to create one, basically with Raylib. So I don't know if that answers your question. I'm trying to create my own emulator. I mean, I barely even started with it. I'm implemented the opcodes at this point. Memory.pc, I mean, I guess so. I have so many cables here, okay. Well, what is this? Adjusts A for BCD addition and subtraction operations. Wow. I've never heard of this instruction before. Addressing modes, instruction opcodes. I mean, what is even the group of this instruction? God damn, alright, I'm just gonna ignore this at this point. DAA. Isn't this the same? Okay, I mean, okay. If the shift flag is set, okay. Alright, so if I'm gonna do this, then I should probably do... Not sure, I did have one. Yeah, here it is. Alright. Okay, so I have to check if the carry flag, sorry, the serial flag is set. This is at the cpu.af.pair.load. That's right. Here I have to do some sort of check. It should probably be. I mean, I don't know if this is the great way of doing it. There has to be a better way of doing this. Okay, apparently not really. I mean, I could set it with this, so I could do flag C, then sorry, 0. No, flexi, no, actually, flag. Which is which? Okay, sure thing. Zero flag is set, which means that I have to jump a certain amount. Actually, no, this is if it's not set. Alright. Then I have to look at this. Basically, that's what I could do. Hopefully, right, and then I just have to copy all this, go down here, paste it, and get rid of this. That should work. But add HL. Okay. HL, interesting. This is only 1 byte, makes sense. Loss equals CPU dot HL dot ping. And that's it. 2 bytes. Okay, so let me just. Do I have the cycle here? Don't think I do. Okay, here it is. Alright, so I increment it by 1. So I fetch and then increment right away. I feel like in functions like this, I should also increment it. But for example, in this one, since I've already fetched the byte that is needed for the subcode and I've incremented, I shouldn't increment again. Probably not. Okay. And this is whoops. All right. I mean, this is 3 bytes. Alright, let me worry about that later. This is technically what should happen. Damn. Okay, so it should be. Alright, wait a minute, I got a message. Where is it? Where is it? Where is it? There it is. Alright, well, until this loads I can keep going. Okay, so it's going to be... So let me... I don't know, 1 byte for the... opcode? I guess 1 byte for... HL. Actually, not, because this is 16 bits, so... Alright, so that's probably where the 3 bytes come from? Not really. 3 bytes. Load. What is this? This is a load one, right? Yeah. I mean, let's just keep going with this one. Load HL. There it is. +1. Okay. Okay. Alright. So the contents of memory address and are loaded to the low order portion of register per HL, register L, and the contents of the next highest memory address and +1 are loaded to the high order portion of HL. Okay, the first N operand after the opcode is the low order byte of NN. So if address 4545H contains 37H and the address 4546H contains A1H, then upon the execution of all the... Okay. Then it will contain... 37H. Okay. I mean, seems fair enough. The only thing is I may have got this completely wrong. Alright. I mean, I kind of get both. Right, I get the current address and then +1. But I don't know if this is the correct approach, because I don't know if, depending on how this is done, should probably maybe do something more simple. Where I just say, okay, so cpu.hl.bytes. In this case, what is it? So we said that the address, so this is on the high end. Okay, no, actually on the low end. Okay, so low equals memory. cpu.pc. No, but I have to get it in one way or the other. Yeah. And then I can do cpu.hl.bytes.high equals memory. And then +1. This seems like it makes a little bit more sense. Okay, let me pause this for a minute. I'm so confused right now. Okay, so NN is a memory address. Okay. Now I do have to get this memory address one way or the other, so that I can load these values in here. Now, how do I do this? Whereas I get, can I do that? Okay, I can go to definition, right. And then I return as a U16, so I return NN itself. Give it an address. Now, I don't really, I mean, I did this, but a couple of weeks ago. So I'm not too sure about the actual address. I mean, this would be like, hey, you have this opcode with this register, and then it's part of the instruction. So I'm not too sure what the address is used for in here. To be honest with you, let me actually go back to one thing. Right. Boom. And which one is it? This one. Alright. Lower the volume a little bit. There we go. Okay, so what am I doing? I don't think the address is needed at all. I mean, it's just part of the instruction itself, so I should just increment the PC and get it from there. That's what I should do. Maybe that's what I'm doing. Maybe yes, because I'm actually using the PC as this. Memory CPU.pc. But at the end of the day, this is not an address really. This is a value, right? So this wouldn't make sense, so it would have to be like this rather than this. This is what I believe, because this would give me the value stored in set place, not the address, which is kind of what I want. Hopefully I'm doing this right. And then, yeah, I just have to increment by 2. Okay, I have to take a quick look at all this stuff. Yeah. So I'm storing whatever is in the address of it. Okay. Up here, for example, memory NN equals that. Because I should probably take a look at this instruction as well. So this is load NN address HL. So this one. Then upon the execution, address contains the lower portion, and then the next one contains the higher portion. Alright, that makes a little more sense. Okay, so let me fix this up. So it would have to be, actually whoops. So this would have to be HL. This contains 48, 38, and the first one contains the lower portion. Then this would have to be bytes.low, and so the next one plus 1. Right. So this kind of makes a little more sense, and then I could do PC plus equals 2. There we go. All right. Actually, now I should probably take a look at all of these different functions. This is fine. This is fine as well. This is what I just changed. This is fine. This is fine. Okay. So LD. Is it in the 16-bit load group? Load group. Does not seem like it. So it must be in the. Except this one loads the value pointed to by DE into A. Okay, this one. The contents of the memory location specified by the register pair DE are loaded to the accumulator. Yeah, makes sense. Makes sense. I mean, yeah, by the pair. Wait, are loaded to the accumulator. So this should be the other way around. What? Opcode 1A. Maybe it's not the one that I have. Maybe it's this one actually. Stores A into the memory location pointed to by the E. Okay, opcode 12, yeah. And then there should be a... this one, right? Yeah. Okay, which is this. There we go. Add system bit rex. Alright, let's just keep going forward. Where was I? Where was I? Where was I? This one, right? Inc L. Whoops. LDL and loads and into L. Okay, LDN. Oh. Sorry, it's the other way around. So if I just have to load in, I guess I should do cpu.etel.bytes.load equals memory.cpu.pc. Alright. CPU, the contents of A are embedded. Once complement. I have to take a look at this one. And change block transfer in search. CPO, right? Yeah. Arithmetic group, CPS. Okay, not that one. Bit reset and test group, not. God damn, which one is it? Exchange block. Is this one L or what? CPI. And this is CPO. CPI? There is a CPI. Compares the value of the memory location pointed to. Okay. Is compared with the contents. Okay, so that's not the one that I'm looking for. Exchange block. Not really. Not really. General purpose CPL. There we go. Alright. So the contents of accumulator register A are embedded one complement. Then upon the execution of CPL instruction, the accumulator contains 01001. Okay, so this is just embedding the actual thing. Alright. So do I just have to do something like this? fn of CPU. Or I can say CPU.ff dot height. Dot CPU dot AF dot height. I mean, that would kind of make sense, because if the accumulator contains 101, then it would be equals not, so that should be it, right? C is not affected, N is set, H is set. So here's the thing, right? I mean, it's probably the script in here. Yeah, N set, and then H is set as well. Alright. So I have to set those up. So CPU.af.bytes.low equals flag H. And then flag N, right? I don't know what I just did. The fuck? Alright. Good enough, good enough, good enough. I believe. Reset. Okay, so I have to reset, not set. Do you use FPGA to connect the Site80? What do you mean by that? FPGA? I mean, I'm not doing anything with like a physical Site80. It's all software, you know? I don't have any physical like computer or anything. I mean, I guess maybe in the future I could try to, you know, test if, I mean, I would have to get a Site80, or rather than a Site80, ZX Spectrum, which is sort of the whole computer with the Site80. But I guess I should try to see if, you know, the code that runs on my emulator behaves and actually works the same as the one on the actual real computer, you know. But that is a work for the future. Right, how far am I? So I'm right here. I still have a bunch of instructions to go, which is not nice. Wow, I still have a lot of instructions to go to sort of finish the, I guess, more basic instructions. But then I also have to do the IX instructions. IX bit instruction, I guess, can wait, and then YI. And then that would pretty much be it. The fuck? That's 1 to B. Wait, but that is already done here. Inc B. That's 1 to B. What? Alright, so I guess I have to discover this a little bit later, but what is the purpose of having... Let me look at the legend. Undocumented. Okay. Bit. IX. Anyways, fuck this. What? Alright. I mean, no, this wouldn't really make sense because I would just have to be more of this. mean, if I want to set it, then this is going to reset, not set. Right. So I should probably do something like this, maybe, and this, maybe. I have no idea about this. Not too confident in this. The bits in the plate. Let's just say using a mask like, I don't know, 000, 001. It's recommended to use or rather than and. Alright. Just wanted to get that out of the way. Use the bitwise or. Man, Joe, what's up? How you doing, man? How are you doing? Alright, so Valiant Mask. Alright, yeah, it's the same thing. Why not and? It would clear bits. Alright. There we go. I'm great. What about you? Great as well, you know. Back in this thing, trying to get some work done. It's been a long time, but yeah. Finally back. Gotta say I've missed this. You know, it's been like what, weeks actually. Let me check it out. Even a month maybe? Shit, I might have gone the entirety of October without doing anything. Alright, so the last one was uploaded October 8th. There you go. The last video, what about live? 3 weeks ago. And that was the 7th. So yeah, almost an entire month. That's crazy. Still working on the emulator, but this is a different one. This is not the Cheap 8. Cheap 8 is already done and finished. This is a Z80 emulator. This is an actual real processor, like in real life. Yeah. Okay. Alright. And then, so this is CPU, we can go into the new row. So function, slope, jump relative, not carry. No, that's going to be it. So if cpu.af.bytes.load and flag carry, but this is not carry. So if the carry flag is unset, right? The fuck? Alright. Okay, so if this is the case, then I have to jump, basically. Okay. Shouldn't be that far up. Shit. Okay, so load SB. What the fuck is SB? Stock pointer? I guess. Load SB NN. It's not a registered pair, that's for sure. I hope so. Let me actually look it up. SP. SP. Wait, it might actually be a fucking register pair. Wait. I mean, I only have SP, but is it the stack pointer? Register per DD defines either BC, DE, HL, or SB. Huh? I didn't know that was a register pair. Alright, guess I have to look it up now. God damn. Stock pointer, that's the only SP I know. And then here it is, there's no, it's SP like. Alright. Alright, you know what? Stock pointer, fuck that. Okay, so if I have to load NN into SP, I guess I have to do const NN equals read NN CPU.pc. Sorry about that. And then I have to say that CPU that SP equals NN. This is what I have to say. And then the rest are unaffected. PC plus equals 2. Alright. Right. So LD NN A stores A into the memory location pointed to by NN. Alright. Sounds reasonable enough. So load NN address A. So I have to store A into the memory location pointed to by NN. So memory. I guess I would have to do const NN equals read NN CPU.pc. Then I have to say that memory. Actually, I don't know what I just typed, but that was a weird ass symbol. Anyways, let me actually look it up. I said it's not in here. Alright, here it is. The contents of the memory location. So if NN contains, then upon the execution of LDA NN, if NN contains a 32H in the memory address, if it contains byte 048, then upon the execution, the is in the accumulator. Okay, so these are loaded into N. Alright, but this is the other way around. 8-bit load group. So, okay. The contents of the accumulator are loaded to the memory address. Alright. That makes more sense. If the accumulator contains byte D7, then execute LD. Instruction results in memory location 3141H. Are loaded to the memory address specified by the operand. Yeah. The first N operand of the opcode is the low order byte of an N. Wow, shit, I might be getting this all wrong. Hopefully not, but. So memory NN equals CPU dot AF dot bytes dot high. And then CPU dot PC plus equals 2. Alright. 31, 41H. So yeah, I mean, I guess this first operand is, but this is not the low byte. After the opcode is the low order byte of a name. That doesn't make much sense. Alright, let's just hope I'm doing all this the right way. Alright. Inc SP. Fn op inc SP transport as well. So CPU data speed plus equals 1. Alrighty, inc HL, so op inc HL address void. So this would be so memory of CPU.hl.pair plus equals 1. Right, and then this is just 1 byte. There we go. Okay, load HL and address N loads N into the memory address pointed to by HL. That's it, right? So this is not in here? Okay. This is the one. Just to make sure. HL N, yeah. So the N integer is loaded to the memory address specified by the contents of the HL register pair. So if the HL register pair contains 4444, the instruction 28H results in the memory location containing the byte 28. Makes sense. So do I have to actually read something? I don't think I do. Let me find another. Read it in, up, B. No, it's just that one. Alright. So I guess it should be like CPU.hl pair equals Alright, having a bit of trouble here. I mean, it can be an address, but it can't be a value either. It can't be the PC itself, right? I mean, maybe it can. I gotta ask memory CPU.pc. Right. Instruction like load N the N value is contained in the PC. What a bad question. Pointed to by the register, yeah. Equals N, yep. Alright. But then I would just have to fetch the PC itself. That's what I have to do. But Start immediately after the opcode in memory. The CPU fetches the user program during the instruction execution. The immediate value to store. So should it? I mean, I guess so. It should be, or okay. So to get the end value, it would be memory PC. Alright. Just wanted to make sure. It's been a while, so I am a bit rusty. SCF sets the curry flag. Sounds simple enough. SCF set carry flag. Right, so if I set the carry flag. Okay, but here's the thing, like in an instruction that says set the carry flag, why do I have to reset N and H as well? I mean, I have no problem doing that, but cpu.af.bytes.low. Let me actually reset all of them. It's just the same way I did this. Alright. So the N and the H, this is reset, and then cpu.af.bytes.low. Sorry, flag. Okay. Alright, there we go. If the carry flag is set, the sign value D is added to PC. The jump is measured from the start of the instruction opcode. Right. If n up jump C. That's basically it. Right. So if cpu.af.bytes.low and flag C, then I have to jump, so let me just grab all of this stuff here. Boom, put it in here. Carry flag is set. Okay. God damn. Alright, it's all good. I mean, is there a list of all the books inside of here? Ducks versus books. Alright, what the fuck is this, man? Computer using computer science compiler design. Oh wow. Hold on. How am I just finding out about this now? Boom. 300,000 stars. Alright. So which one's next? This is done. Add HL HP SP. Add HL SP. It's kind of insane. I need to give it a return type. As defined. Fuck. The value of SP is added to HL. Okay, so CPU added cell.pair equals this is 1 byte. All right. we go. Have to get an N, which is read an N with the CPU.pc. Alright, and then I have to do memory edit. But there's probably a better way of doing this. Is there? Alright, let me actually look it up. So this is load AN. So load AN. So if an N contains and the memory address contains byte 04. Okay. So that's pretty much it. Shouldn't be a problem in here. Let me just check the bytes of this instruction 3. So I should do CPU. What am I doing? CPU.pc plus equals 2. Alright. Sounds good enough. Sounds good enough. Sounds good enough. Is there any sort of flag that I have to take into account? Unaffected, unaffected, unaffected. Alright, there we go. Op deck sp boom boom boom. So CPU dot sp minus equals 1. Boom. Inc A. I haven't done this already. God damn. Alright, so fn op a CPU.af.bytes.high plus equals 1. Is there any sort of reset? As defined, as defined, as defined. Okay, I have to actually fucking take that into account. Alright. Well, if I have to reset 1, I mean I have to reset, and so I guess detects overflow. PB detects overflow. Alright, that's something that I have to look at for sure. Deck A. Void. And then CPU.af.bytes.high minus equals 1. Okay. I think I'm gonna do up until CCF and that's it. Fn op load AN, which seems like a pretty basic function just to be like this far into the program, but whatever, to the list. Loads N into A. Sounds reasonable enough. So CPU.af.bytes.high equals memory PC. Sorry. CPU.pc. Okay, that's all I have to do, right? It's 2 bytes. Sure thing, but so do I just have to do CPU.pc plus equals, I don't know what just happened there. What is the first one? Was load BN. Yeah. So I just have to do that. Alright. Fn op. This is CCF. So if I have to inverts the carry flag. So CPU.af.bytes.load. And then I just have to invert the carry flag. Alright, that's interesting. How can I invert this without modifying the rest of the bits? This might be a little... XOR, god damn. So I should just do an XOR of the mask. Alright. Please let me do this. Yo. Alright. This is the C flag, right? Carry flag, yeah. Flag C. Boom. Alright. And then let me do one thing because I have to get so many of these things done correctly. Alright, so let me do 17 is what? Well, this is going to be a long day. Actually, let me do one thing. Get rid of this, and I can do git commit got all the instructions up until CCF, which is opcode 3F. Opcode 3F done. Although the arithmetic ones have to or need to check and modify the flags as intended, I guess. Intended. Main. Now I can go in here, set 80, and then I can just take a look at what instructions it does. So the last one is LDD. Alright. So the next one should be early. All right. Going to be a while here, but fuck it. This is op, jump, relative. Do I not have this? The fuck? Hold on. Yeah, D. Yeah. Jump D. Oh, is it just jump D? Or why might I have to change that? Should be add HL D. All right. Actually, am I not doing this the wrong way? Like, actually no. Okay. Okay, now I should do 1A, right? And then 1A is LDDE, right? LDD address A, right? Yeah. Whoops. All right, there we go. And then Giant relative Nazi. Yeah. How many do I have left? Oh wow, I have a bunch of them left. Anyways, right. Let me just get back into it. Up ink HL. Right, but this is address HL, so this is ink HL. LDHN. Okay, that is not done, but definitely needs to be done. Okay, so deck, HL, whoops, HL. So this is ink, HL. Ink L, okay. Here we go. LDLN. CPO, giant relative. Whoops, giant relative. Carry. We go. ABCD. Whoa, 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 whoa. Hold on. Alright. So this is. And this should be LDSPN. LDSPN. Whoops, there we go. OP LDNN underside. OP LDNN. Inksp. LDHL address. .36 is SCF. Okay. HLSP 9 an address and an address. Boom. Deck SP Inc. A. Deck A. CCF. So this is 3D, but I don't think that's where I left 3F. Interesting stuff here. So I'm missing one. Huh. Alright, so either there's a duplicated number here. Well, not really. There should be a jump rather than a duplicated number. ABTCF 0, 1, 2, 3, 4, 5, 6, 7, ABCDF. Actually, let me. Alright. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, F. Alright. 0, 1, 2, 3, 4, 5. A, B, C, D. Damn, I'm missing one instruction. What the fuck is going on? Maybe this one? But I think this one was already set. Yeah, shadow. There it is. So this is implemented here. So here's this one. So 1, LDBCNN. 2, LDBCA. Alright. Inc. BC. Wait. Alright. 03. BC. Inc. B. Deck B. PN. Relay. Shadow. At. BC address. Deck BC. Inc. C. Deck C. LDCN or RCA. Yeah, this is done here as well. Okay. LDNN, Money, Inc. D, Inc. D, Deck D, RLA, Jump Relative, HLDE, okay, Deck D. Alright, Inc. D, Inc. E. Okay. Wait a damn minute. It's not Inc. D, it's Inc. E. Alright, there we go. Alright. Just have to make sure. where are we? Inc E is 1C. Right, so 1C, Inc E. LDEN, 3, yeah, generally not C. D, yep. 1F, actually. One F is RA. So what's going on here? So here's the problem. Here's the problem. A, B, C, D, F, yes. 0, 1, 2, 3, 4, 5, 6, 7. 8, 9, yes. 0, 1, 2, 3, 4, 5, 6. 1, 0 is decrement. Okay, so here's all fine. 1, 1 is LDNN. What? So maybe here Inc D, deck D, no. And deck D is 15. Alright, so the next one is LDDN, which is 16, 17, 18, 19. Add HLDE, yep. Then this as well. B deck DE. Inc E. Oh, there it is. There's no deck E. God damn. So D is deck E, which I don't have it. Great stuff. Inc E. I don't know why, but I don't have it. Deck. Alright. I just have to change all of this again. So this is E, F, sorry, F. This is going to be 2, 0, 1, 2, 3, 4, 5. That's not what I wanted to do. That's not what I wanted to do. 5, 6, 7, 8, 9, A, B, C, D. Next I get counts. E, F. Right here as well. Now you are 3, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, A, B, C, D, E, F. Alright. Yeah, I got an error. It turns out I cannot do that. Well, that's going to be a problem for me in the future. Let me just do git add, git commit, add all the new opcodes to the init tables function. Alright. Main. I don't give a fuck about it. I gotta go. That's going to be it. Thank you guys for being here. Most likely I'll be back either this afternoon or tomorrow.